In this video, I will show you how to find the tangent of 2 theta, sine of 2 theta, or cosine of 2 theta if you're given one trig value and the quadrant. So first of all, this statement over here, theta is between 180 and 270. That's just an indirect way of giving you the quadrant. So this is going to be quadrant 3, because that's between 180 and 270 degrees. So go ahead and draw the terminal side of the angle in the third quadrant like this. And go ahead and make a triangle out of it as well. Okay, now let's talk about x, y, and r. We know that cosine is x over r. So x over r. We know that the radius has to be positive. So this negative sign, I'm just going to go ahead and clearly put it on the 5. So the x value, which would be right here, is negative 5. The radius is 13. So all we need is the y value. So we would do the Pythagorean Theorem, and this would come out to be negative 12. Okay, I've memorized this one, 5, 12, 13. It's one of those Pythagorean triples, but you could do the Pythagorean Theorem to find it. Of course, it has to be negative because this is down, all right? So a y value would be negative in the third quadrant. All right, so now we are all set. Tangent of 2 theta. We've got this formula that says tangent of 2 theta is going to equal 2 tangent theta over 1 minus tangent squared theta. So we're just going to employ that formula. So we're going to have 2 tangent theta over 1 minus tangent squared theta. Okay, so what is tangent? So remember, in terms of x, y, and r, tangent is y over x. So that's going to be negative 12 over negative 5, or simply 12 over 5. Okay, so that's why I will have 2 times, and so like I said, the tangent of theta is just going to be 12 over 5, and then I'm going to have 1 minus 12 over 5 squared. So it's really just a matter of simplifying this. Okay, so in the numerator, I'm going to have, because this is like having 2 over 1, and you just multiply straight across, so this will be 24 over 5. Now down here in the denominator, first if I square these, 12 squared is 144, so I've got 144 over 5 squared is 25, so I'm going to have 25. Now how about this 1? 1 is like a chameleon number. I can write this as 2 over 2, 3 over 3, 4 over 4, etc. But right now I'm going to write it as 25 over 25 so that I will have like denominators. Okay, so now I can go ahead and put these together. So in the numerator I still have 24 over 5. And now in the denominator I have 25 minus 144 over 25. Okay, I'm going to make a new column and bring my work up here. So I have 24 over 5 still in this numerator. And of course, 25 minus 144 is negative 119. So that's negative 119 over 25. So when you divide with fractions, you multiply by the reciprocal. So I'm going to have 24 over 5 times 25 over negative 119. Now 5 divides into 25 5 times, so I've got this. Now 24 times 5 is 120, so now I have 120 over negative 119. So this will be the final answer. Let's do a couple more. Once again, this is telling me that we are going to be in quadrant 3 because that's between 180 and 270. So draw yourself a little sketch into the third quadrant. Here's the terminal side of the angle theta, and I'm just going to make a triangle out of it so we can talk about x, y, and r. Cosine, well, I'm recognizing this as a special angle. We've memorized that the cosine of pi over 3, sorry, the cosine of pi over 6 is radical 3 over 2. So the fact that this is negative radical 3 over 2 tells me that the reference angle is pi over 6. Okay, so that means that this reference angle right here is pi over 6. Now we're supposed to find the sine of 2 theta. So let's remember the formula for that. Sine of 2 theta will be 2 sine theta cosine theta. So we will just do 2 sine theta cosine theta. Now, we already know that the reference angle is pi over 6. So the sine of the angle is going to be either 1/2 or negative 1/2. And that just depends on the quadrant. Because the reference angle is pi over 6, but the actual angle is this. Okay, because of the reference angle, I know it's going to either be 1/2 or negative 1/2. And in the third quadrant, sine is negative. So we'll say negative 1/2. Cosine, we were given cosine in the first place, so that's going to be negative radical 3 over 2. So it's just a matter of simplifying all of this. Now these 2's will cancel each other out, and a negative times a negative is a positive. So that's just going to leave positive radical 3 over 2. So that is going to be the final answer. Let's see, between 0 and 90, well, this is going to be a little extra easy because between 0 and 90 is the first quadrant. So here's a little sketch, okay, of my angle theta. Now this is not one of the special angles, so that means I need to think about the Pythagorean theorem. Now tangent, in terms of x, y, and r, tangent is y over x. So that means this must be 4 and this must be 3. Now I need to know what r is. The radius is going to be 5. So if I didn't have that memorized, I would do the Pythagorean theorem. But 3, 4, 5 is so common, I've memorized that. So now it's time to do cosine of 2 theta. We actually have 3 different versions of the cosine formula. It doesn't really matter which one you do. I think I'll just do cosine squared minus sine squared. Okay, so I'm going to have cosine squared theta minus sine squared theta. So what is the cosine? Well, remember that cosine theta is going to be x over r. So in this case, cosine of theta is going to be 3 over 5. Okay, so cosine squared is going to be 3 over 5 squared. Okay, sine squared, all right, sine theta is y over r. So in this case, sine theta is going to be 4 over 5. So sine squared is going to be 4 over 5 squared. So this is going to be 9/25 minus 16/25. So this is going to make -7/25. And that is the final answer. So looking at number 28, between 180 degrees and 270 degrees, once again, that is the third quadrant. So just draw yourself a little diagram with the terminal side in the third quadrant, make a triangle out of it. Okay, 15 over 8 is not a special angle, so I'm going to do the Pythagorean theorem. In terms of x, y, and r, tangent is y over x. Now, considering that this is the third quadrant, x and y are actually both negative, so this is really -15 and -8. It's just that a negative divided by a negative is a positive, so that's why they didn't put it. But in my diagram, I'm going to put -15 and -8 because it's left and down. So we need to find r. So this is not one of the triples I have memorized, so I'm going to have to do the Pythagorean theorem. So r squared is going to equal -8 squared plus -15 squared. So that's going to be 64 plus 225. So that's 289. Then if I do the square root of both sides, that's going to give me 17. So the radius r is 17. So now I can go ahead and find sine of 2 theta. The formula for this is 2 sine theta cosine theta. Right? I'm just pulling that right off the formula sheet. Okay, but sine theta, sine is y over r. So that's going to be -8 over 17. So -8 over 17. Cosine is x over r. So that's going to be -15 over 17. So it's just a matter of simplifying this. Notice that a negative divided by a negative is, a negative times a negative is a positive. So I'm going to disregard the negative signs. So this is going to make, just multiplying straight across, 17 times 17 is 289. Okay, so it's just a matter of what this is. And that turns out to be 240, so this is the final answer. Number 29. Well, this video is just loving the third quadrant, so here we go again. Between 180 and 270, that's the third quadrant. So here's my little diagram. Okay. This ratio is not one of my special angles, so I have to do the Pythagorean theorem. I know that cosine, in terms of x, y, and r, cosine is x over r. The radius always has to be positive, so this negative sign is really on the 3. So it's -3 over 5. So that's why I'm going to have a -3 right here, and the radius is 5. If this wasn't one of the triples that I've memorized, I would have to do the Pythagorean theorem. But I know that this is a 3, 4, 5 triangle. Now, I will make this a -4 because this is down and y values are negative in the third quadrant. So now I have x, y, and r. So I should be good to go. Okay, so cosine 2 theta, again, there are three formulas that you have, but I'm going to do cosine squared minus sine squared. Okay, you get the same answer no matter what. So cosine squared minus sine squared is one way to go. Okay, well, cosine is x over r. So that's going to be negative 3 over 5 squared. Sine is y over r. So that's going to be negative 4 over 5 squared. So that's going to be positive 9 over 25 minus 16 over 25. So that's going to be negative 7 over 25. And that will be your final answer. All right, this is the last problem. Between 270 and 360, that is going to be the fourth quadrant. So go ahead and draw a sketch with the terminal side in the fourth quadrant and then make a triangle out of it. Radical 3 over 2. This tells me that theta is one of my special angles. The cosine of pi over 6 is radical 3 over 2. Okay, so that tells me that the reference angle is pi over 6. Okay, so this reference angle right here is pi over 6. So keep that in mind. Now, I'm going to go ahead and do tangent. So the formula for tangent is the tangent of 2 theta is going to be 2 tangent theta over 1 minus tangent squared theta. Okay? 2 tangent theta over 1 minus tangent squared theta. So, what is tangent theta? Well, the reference angle is pi over 6. So that tells me that the tangent is either going to be, because look, I know the tangent of pi over 6 is radical 3 over 3. Okay, sometimes I call this 1 over radical 3, same thing. So since the reference angle is pi over 6, that means the tangent is either going to be positive or negative radical 3 over 3. So it's just a matter of whether or not it's positive or negative. And that's just based on the quadrant. In the fourth quadrant, tangent is negative. Tangent is negative in the second and the fourth quadrant. So I know that tangent of theta is going to be negative radical 3 over 3. So that's what I'm about to do. All right, so I'm going to do 2 times negative radical 3 over 3. And then I'm going to have 1 minus negative radical 3 over 3 squared. So it's just a matter of simplifying this down. So in the numerator, I'm going to have negative 2 radical 3 over 3. All right, this is like 2 over 1, and I'm just multiplying straight across. Now in the denominator, first let me deal with this squaring part. If you square something, it's going to be positive. So that little negative sign is going to go away. If you square radical 3, that's going to become a regular 3. All right, radical 3 squared is 3. Of course, if I square 3, I'm going to get 9. Okay? So this is really going to be 1/3. You know what? Yeah, I'm going to go ahead and do that now. So that will simplify it down to 1/3. Now this minus sign didn't go anywhere, so that's still there. Now the number 1 is like a chameleon number. I can write this as 2/2, 3/3, 4/4, whatever I want. But in this case, I'm going to choose 3/3, so I have like denominators. Okay, so now I'm going to have -2 radical 3/3 over, so 3 minus 1, so that's going to be 2/3. Okay, now notice that I have the same denominator, okay, in both of these fractions. Those are going to cancel each other out. So therefore, the final answer is going to be -2 radical 3 over 2. I'm sorry, did I say that was the final answer? Because now those 2's will cancel out. So the final answer is going to be negative radical 3. All right, notice the negative doesn't go anywhere. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.